For this video, we are looking at trying to come up with the graph, what is the formula for the graph that we see here. And I think it might be helpful to take a step over to look at how do I say this, a standard tangent graph would be. So on Desmos, I set this up, so I did steps of pi over 2, did from negative 3 pi to 3 pi. But let's just focus on this one here. And here's our standard tangent graph. And I want to point out here at pi over 2, that's an asymptote. Negative pi over 2 is an asymptote. So pi is one full period there. You know what might be helpful? I think we're still good. Okay, so I think we see if from 0 to pi over 2 is there. So if you can see, follow the arrow, where this is here, that must be pi over 4. If you go up, that's 1. So we know it goes through pi over 4, 1. In fact, you know what I think I might do is do a screen capture of this, and I can draw on it. Okay, so now I'm over here where I can draw on it. Things I want to point out is that here we have pi over 4, and here we have negative pi over 4. This is 1, and this is negative 1. So this point here would be pi over 4, comma 1, and this would be negative pi over 4, comma negative 1. Now, this is important in determining what our stretch factor might be. So what I want to point out is, I know there's a grid line there and there, but there's our in a standard one that's not shifted at all, we have our origin. Then if you went over to pi over 4, then up goes to 1, or negative pi over 4 to negative 1. And that what I'm trying to get at is these values are, change back to, I like blue. Come on, blue. So that these values that have a normal crossing, when I say that, integer crossings for the y values are going to be at 1 and negative 1. So 1 above where it started, and one down below. That's my point is down. We're going down by 1. We're going up by 1. So let's go back up here. Look at the problem in question. And they give us some clues to help start it out. So first of all, they say, given the period of the function whose graph is shown. And this person got everything correct, but I thought I'd explain it because that question came up. So this is a place, and here's a place where it's crossing. And to me, this is telling a lot because, like I'm thinking down, it's shifted down. So that is from negative 1 to 1, so our period is 2. Now, normally the period is going to be pi. So our pi over b will equal 2. So b over pi, if I do the inverse, is 1 over 2. So b would be pi over 2. So when I'm putting this together in the formula, b is pi over 2. Okay, what is the next thing? Give the positive vertical stretch factor. So this is a tough one. This one in particular is pretty tough because I'm looking for any values. And now let's just think about this. Normally it's going to go, let's go back down to here. Normally it's going to go from negative pi over 2 to pi over 2. But the one we're dealing with is going from negative 1 to 1. Isn't that what we came up with? Yeah, negative 1 to 1. Granted, it's shifted down. And I think I detect a horizontal shift then too, because it should be going through the origin. Or you could say this should be there. So however you want to come up with that. So let's think about that. If normally it would go from negative pi over 2 to pi over 2, so some important values, negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. If we're looking at those, now we're dealing with one that -1, and then we have 0, and then we have 1. So halfway in between here is 1/2 negative, and halfway in between here is -1/2, or +1/2. So at 1/2, where's it going? Look, it's like it's down at 6. At -1/2, where's it going? Looks like it's up at 2. And so that what's odd about this is these aren't hidden regular cross grid lines, so that's harder to interpret. So normally what we would have seen, it would cross a regular thing at 1. Now it's crossing it at 4. So from here to there, it's a 4. And that's why we have a stretch factor of 4. Because it's normally 1, but 1 times 4 is 4. It's a stretch of 4. Okay, so that gives us actually our leading coefficient. I'm curious if they went with this with a cosine, or sorry, cotangent or a tangent. It's like they could say -4, and it's an inverse cotangent, or not inverse, but a reciprocal. Okay, and they did do that. Okay, and so the vertical shift. Well, because I found these major cross points down by 2, that must be a -2, where the -2 came from. So to put it all together, we calculate our B. And if I don't do they don't even talk about horizontal shifting. So assuming that, I'm not going to go tangent, I'm going to go cotangent, but consider it reflected, so negative on front. Hang on a second. Okay, so here is the cotangent graph. So notice it has an asymptote here at 0. We'll change colors there. What's a good asymptote color? Green? Doesn't look like a good asymptote. How about orange? Will that show up enough? It doesn't really. But okay, so asymptote there and asymptote at -pi and at pi. So still the same period being pi, but our asymptotes would be the vertical asymptote, sorry, the y-axis is a vertical asymptote. And that's one of the tricks I've noticed on these problems. If it doesn't include any horizontal shifting, you look to see if the center is going through the origin or somewhere around the origin, if some major activity is happening around the origin, or is the y-axis an asymptote. Okay, so, but you notice this is going down, where the one we have is going up, and that's why we have a -4, because it's reflected. So scrolling back up here to this work part. Okay, so because it's going up instead of down, like it should be for a cotangent, we do our -4 as leading coefficient, cotangent of, and we have our pi over 2 times x, and then -2. And that's what the person has here. So this pi over 2, that's our B. That -4, that's the A. So I know this is kind of a long video. I tried to explain it with some other examples, so hopefully that's helpful for you. Let me know.